Hi everyone. Right now I'm going to cover the binomial theorem, and so make sure you have a pen and paper ready so that we can start. So I'm just going to write binomial theorem. Okay. So the first thing I kind of want to show in order to sort of explain the binomial theorem is we're going to sort of draw Pascal's triangle. So if you remember Pascal's triangle, it's 1 and then we go like 1, 1, and then we go like 1 at the end. So the edges are always 1, and the middle term is the sum of the previous two. So that's 2, 1. So it's 1, 2 plus 1 is 3, 2 plus 1 is 3, and we go 1 over here. And basically it just keeps on going. So I'll just do one more. Just 1. This is 4. This is 6 because 3 plus 3 is 6. This is 4, and this is 1. Okay, so let's see, well, how does this matter, or why is this important? Well, let's try something else. So let's try the expansion of, say, x plus 1 to the power of 0. So if you know what that is, x plus 1 to the power of 0 is actually equal to 1, because anything to the power of 0 is equal to 1. So that's what it's equal to. Let's try the second term, x plus 1 to the power of 1. And what that is equal to, it's 1x plus 1. Okay, so notice how these 1s are kind of repeating themselves. All right, so let's try another number. Let's try x plus 1 squared. So if you know what that is, that's just basically 1x squared plus 2x plus 1. Very interesting. 1, 2, 1. I see 1, 2, 1 over here. Let's try, x plus 1 cubed. And if you know what that is, that basically ends up, and you can trust me on this is 1x cubed plus 3x squared plus 3x plus 1. Interesting again how it's 1, 3, 3, 1. So it's 1, 3, 3, 1. And let's just do the last one just because we have it right there. So it's x plus 1 to the power of 4. And what that will equal is, oh, you know what? I'm just going to move it a little bit. I'm going to move this one just a little bit to the left so I have some room. And what this one is, oops, sorry, that's not what I meant to do. What this one is 1x to the power of 4 plus 4x cubed plus 6x squared plus 4x plus 1. So once again, we sort of see this sort of pattern forming again that follows the Pascal triangle. And what we're going to do is sort of investigate why that is. Why is it that this expansion follows that Pascal triangle? And once we figure out the secret, given any sort of binomial, it's called a binomial because there are two terms. This is the one term, and that's two terms, and we're going to expand them. And so once we crack the code, we can, given any two terms and whatever power, we can figure out what the expansion is going to be equal to. So our goal basically for this unit is going to be, I'm just going to scroll down a bit, let me just get to white again, is going to be the binomial expansion. And really what we're trying to investigate is if we get ax plus by, really this is just the first term and this is just the second term. It's called binomial because there are two terms to the power of n. How can we expand any of these? So really there are just two terms here. So two terms over here. Okay, and in order to do that, we need to understand something about combinations. So I'm going to explain what a combination is. So combination, and we'll see basically how this sort of comes into play in a second. But let me just explain what this is. So say for example we write something in this form. What this is equal to is n factorial over r factorial over n minus r factorial. And if you don't remember what n factorial is just basically equal to n times n minus 1 times n minus 2 times ... all the way to 1. So in other words, So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. So this thing over here is going to sort of help us determine how we get those numbers. So I'm just going to show you an example of it. So say for example, if I have 5 combination 2, so we commonly say it's 5 choose 2. So we can write this as 5 factorial over 2 factorial times 5 minus 2 factorial, which is basically 5 factorial over 2 factorial times 3 factorial. So if we expand everything, this is 5 times 4 times 3 times 2 times 1, all over 2 times 1, and then 3 times 2 times 1. So if you can observe, we can start canceling some terms. So the 3's cancel out, the 2's cancel out. We're not going to worry about the 1's. This 2 will cancel out with that. So 4 divided by 2 is 2. So all we end up with is 5 and 2. The rest are 1, so they don't really matter. So this is equal to 10. All right, so it's really important to understand how this combination works. So just remember that it's n choose r, it's n factorial over, let me just scroll up here just a little bit. So it's n factorial over r factorial times n minus r factorial. So it's very important to understand that. In the next video, I will basically start explaining how the n factorials come to play and why we need it. All right, so see you in the next video.